All right, so in this video, I'm going to give you a very brief explanation of how I did step 2 of the 5th 6 weeks project. So hopefully you guys are paying attention because this is slightly new information for most of you guys. This is called Newton's method. Its purpose is to approximate x-intercepts, just like Bolzano's theorem is. Just Newton's method is slightly different. I will point out that Newton's method is in your textbook, chapter 3, section 8. There's a whole chapter section about Newton's method, so feel free to look there and see more examples and more of a slightly longer explanation about this information. Now notice, I still have all of my information from step 1 written up here at the top, and so one of the things that you're going to want to do is make sure that you keep all this stuff here or make any corrections that you needed to from the first step. One of the things I'm going to do to try to make myself just make it look a little bit cleaner, make it look a little neater, is I'm going to add kind of like this breaking line just to break up step 1 from step 2. The way I'm going to do that is I'm going to come up here on my keypad in between the 0 and the equal sign, and I'm going to hit the dash button, but I'm going to hold down shift and I'm going to hit the dash a couple of times. Gives me a nice underscore, and when I hit enter, it automatically corrects and says, hey, you really want this nice pretty line here. And what I'm going to do is I'm going to actually get rid of some of this extra space down here. Remove space after paragraph. Yeah, that looks pretty good right there. I think that looks pretty nice. At least it breaks it up so that I can tell step 1 on top, step 2 kind of here in the middle, and it still saves us room down here at the bottom for step 3. Now that I've got that done, again, Newton's method is designed to approximate the x-intercept of a function. Again, we want it to be continuous, and what it does is it uses the linear approximation. So I kind of wrote some steps here for you to kind of help guide you. But remember, you need to give at least a brief explanation of what Newton's method is. And I'm also going to make sure I mention I'm going to make here a 3 by 2 table. So 3 columns, 2 rows, just so you guys can kind of see what I'm doing a little bit more clearly. You could, if you wanted to, I'm going to go up here to layout. You could make your margins a little bit wider or a little bit smaller if you want to. You could go with an arrow. It's really just up to you. You may want the extra space. You may not want the extra space. But what I'm going to do is I'm going to label these columns. The first one as the first iteration. The second one as, whoop, I used an N in there. And the second one is going to be the second iteration. And it's going to be the third iteration. Now, in case you are wondering, in case you've never heard the word iteration before, all it means is that I'm repeating the same process over and over and over again, and the iteration is each time you repeated it. It's kind of like the word trial. You know, an iteration is very similar to a trial. It's just how many times do I have to repeat this process. So notice the first thing I need to do is compute the derivative. So I'm going to come up here, and I'm going to actually give myself a little bit of space. So step 1 is compute the derivative, and what I'm also going to do is I'm also going to go ahead and rewrite my equation just so I have it one more time. Instead of typing it all over again, I'm probably just going to copy and paste. You know, it does make things a little bit easier instead of having to retype the whole thing. But I do want to go ahead and have my derivative in here. And let me get rid of this extra line in here. So go to insert, go to symbols, go to equation, or you could do the alt equals. Again, that's the keyboard shortcut. Remember, the derivative is f apostrophe of x, f prime of x, and so my derivative is 5x to the 4th plus, I got it written down, 96x cubed plus 225x squared minus 4292x minus 17836. All right, so there's my equation, there's my derivative. All right, next step, step 3, plug this x value into the original function. Oh, sorry, I skipped step 2. Step 2 says choose one of the bounds of the interval provided. The interval that I was given, or the interval that I used, was -2 to -1 earlier. Does not matter which one I choose. I'm just going to go with the -2. That's what I did when I wrote down all my calculations. So I'm going to write down choose x equals -2. I'm going to actually give myself a little bit of space so I can work with here. So add a little bit extra space after that. And so my first equation, first thing is plug this x value into the original function and the derivative. So I need to find f of -2, which I did earlier. Notice we did that in step 1. That's 4,800. So 4800. I'm also going to go ahead and find the derivatives value at -2, which I did earlier. It was -9040. Now that I've got those, again, I'm going to come back up here and I'm going to add a little bit of space so I'm not sitting right on top of stuff, so it's nice evenly spaced out. And I'm going to go ahead and write the linear approximation equation, which is, and I'm going to use y equals, remember the derivative gives me the slope, so the -9040, we're going to do parentheses x minus a, so x minus -2 gives me +2, and then I'm going to add that y value, the f of -2, which is 4,800. All right. For the next step, for the next thing in my process, step 5 says use the linear equations, step 4 says use these values to write the equation of the linear approximation. Solve for the linear equation's x-intercept is step 5. So what I'm going to do here is I'm going to find the x-intercept of the linear equation. And the way I'm going to do that, and I don't really have to show this work, is I'm going to set 0 equal to -9040 parentheses x plus 2 plus 4,800. You solve this equation and you get the answer. I'm going to skip down. I don't need all this extra work. I'm going to skip down and I'm going to write x equals. And the final answer that I got here for this first iteration was -1.46903. All right. So that's the important part there. I am going to highlight that, and I am going to change its color. I'm going to make it blue because I like blue. So there's my first iteration. Now, step 6 says use this new point to repeat steps 3 through 5 until the estimate has the desired precision. So I'm going to use an arrow, insert shape. I'm going to draw myself an arrow from here up here, and I'll make sure the color is the color I want. I want it to be that color. And I'm going to say choose this x value, x equals -1.46903. And I'm basically going to just follow the same process. Find the y value, find the derivative value at -1.46903 equals, let me find my answers. I got -602.43069. for the first one, and then when I found the derivatives value, 903, I got -11,326.43441. Now, you probably recognize that it's going to be a really tough challenge to write all those decimal places into this linear equation, and it still fit into this box. Well, here's the thing. I've already got all the decimal places I need. I've already got all 5 decimal places. So when I'm writing down the answer, I'm probably not going to include all the decimal places. I might just test and see, okay, I can do 11326.43. We'll do the x plus 1.469, so 1.47. And then I'll do minus 602.43. Yeah, that still fits in here, but like I said, I've got the desired decimal points here in my work. I don't really need to write them here as the next step. So like I said, I'm probably not going to list all those decimal places here just because I've already got them written down. It seems a little redundant to have them all written down again, but do remember to use all those decimal places in the calculation, because here's the thing. I've already done all my calculations. At this point, I'm just writing them down in the paper. All the math is already done. At this point, it's just technology. So when I solved for the x-intercept, I got -1.52221. Again, I might come up here and highlight this equation or this value and make it blue. And I might come down here and I might highlight this one. And I like green too. I'll make that green. So for this last one, what I'm going to do, again, is I'm going to go up here and I'm going to insert a shape. I'm going to do the arrow, and I'm going to draw my arrow up here like this. Again, I might just want to change the color so that it's also green. So choose x equals the negative 1.52221. And just follow the same process. When you're done, make sure you write down your answer down here at the bottom. So I'm going to call it the estimated x-intercept at x equals whatever your answer you get. So again, just make sure you are keeping yourself in mind when you do this. And again, you only have to do the iteration 3 times. So there was my first, my second, my third. Again, probably the longest the longest part of this project is the actual calculation side. Once you get through the calculations, putting it on this chart really won't take too very long. But again, make sure you include your Newton's method reasoning. Make sure you include your equation and your derivative. Please make sure you are using those equation editors. And again, please show these steps for the iteration. Show what your x value you chose. Show what you got when you plugged in for the original function, for the derivative function. Write down the linear approximation equation, and then write down the answer. Draw the arrows so that I can follow along what you're doing, and anybody else could follow along with what you're doing. So hopefully that gives you an idea of what you are doing with this. And good luck to you. Let me know if you have any questions. Have a great day. Bye.